Hello, my name is Mr. Fall, and in this video we're going to cover electron and molecular geometry, aka VSEPR, for what you need to know for organic chemistry. So let's start over here with atoms that have 4 electron domains. When I say 4 electron domains, that means there's 4 places around that central point where you can find electrons that are going to repel each other and spread out as far as they can. Okay? So the 3 molecular geometries that fall into that category would be tetrahedral. And in this case, there's no unshared pairs. There's 4 atoms bonded to the one central atom, no unshared pairs, and they're going to spread out about 109.5 degrees. Okay, that's as far apart as they can get in 3 dimensions. And then after that, if you replace one of those atoms bonded with an unshared pair of electrons, you're going to have a trigonal pyramidal molecular geometry. Now, the unshared pair, because the unshared pair of electrons is going to sit closer to that central atom, it's going to repel the other atoms a little bit more and squeeze them together a little more. So you get a slightly smaller bond angle, roughly 107.8, depending on what those atoms are that are bonded. And then bent, 2 atoms bonded, 2 unshared pairs. So all 3 of these molecular geometries have 4 electron domains, meaning there's 4 places around the central atom where you can find electrons. Okay? So that means if we're looking at just where the electrons are, we would describe their electron geometries as tetrahedral, because they're 4 electron domains. Okay? Now, what if you have 3 electron domains? Well, then you're going to have a trigonal planar electron geometry. And the 2 molecular geometries that we have that would fall into this category would be a trigonal planar molecule, and that's when you have 3 atoms bonded with no unshared pairs. The furthest they can spread out is 120 degrees. We also can have bent, not the same bent, when you only have 1 unshared pair of electrons and 2 atoms bonded, there's 3 places the electrons are really pushing from. And so it's going to be close to 120 degrees, but similarly to before, since there's only the unshared pair of electrons is going to push the other atoms closer together. So since there's 3 electron domains, they're going to take a trigonal planar electron geometry and be roughly 120 degrees apart. And then the second to last molecular geometry you need to know is the linear shape. So typically it's going to be a central atom with 2 atoms bonded to it and no unshared pairs. You can also call anytime you have 2 atoms bonded to each other, like in a diatomic molecule, that's also linear by definition. It's just one connection, right? So that molecular geometry, linear, 180 degrees apart. Its electron geometry would also be linear. We do have, however, other linear molecules that don't have a linear electron geometry. So I'm going to first introduce a molecule, PF5, which has an expanded octet. And it's the only expanded octet geometry I'm expecting you to know. And that's when you have 5 electron domains. Okay? So PF5, no unshared pairs, but it's 5 atoms bonded. That's going to be called trigonal bipyramidal. And you're going to have 2 bond angles in this. You're going to have 3 atoms in one plane. So they're going to spread out 120 degrees apart. That's like you have a trigonal planar molecular geometry. But then, like, if you took an atom and stuck it to both sides of that, or out of the top and the bottom, that's the shape that you're going to get. So you're going to get a 90-degree bond angle for the one sticking out of the top and the bottom, and then the 3 in the same plane are going to be 120 degrees apart. So that's a molecular and electron geometry that's trigonal bipyramidal. So there are some molecules like xenon difluoride, which I drew the Lewis structure over here, but don't worry about that. We have those. It's basically a trigonal bipyramidal electron geometry, but it's still going to make a linear molecule because the bond angle between the atoms is 180 degrees. Okay. So now, again, just to reestablish, electron geometry looks at the shape based on where the electrons are. The molecular geometry is like if you just took the atoms and looked at where they are in space. Okay. Now, for any of these molecular geometries, they're going to be identical to the electron geometry, provided that you have no unshared pairs. So notice, a tetrahedral molecule is going to have a tetrahedral electron geometry. A trigonal planar molecule is also going to have a trigonal planar electron geometry. All right? And a linear molecule is also going to have a linear electron geometry, providing they have no unshared pairs. So that's science.